Alright guys, so 1.4 notes is what we're going through today, and it is solving and graphing absolute value functions. So yesterday we did do some graphing of absolute value functions, but I want to show you a different way how to do graphing of absolute value functions. If you want to do it that way, by all means you totally do not need to do graphing of absolute value functions this way, but I do want to show you another way to do that that might click better with you. Anyway, let's dive right in. So, notes. What is the absolute value? Absolute value is the distance a number is away from 0. Is the distance a number is away from 0. Okay? Distance is always positive. You never would measure in a negative distance. So distance is always positive. So that's just really good stuff to note with absolute values. So warming up here. If the absolute value of x equals 7, what are our possible values? Well, the possible values would be 7, or you could do negative 7, because both of those have a distance of 7 away from 0. If the absolute value of x is equal to negative 4, what are the possible solutions? Well, we just said absolute value has to be positive, so it can never be negative. So then what we would say here is that there is no solution. There's no possible number for us to plug into x and then get out negative 4. So we have no solution right there. All right, so how to solve absolute value equations. First step, isolate the absolute value expression. That means get it by itself. Okay, make sure nothing is being added to it or subtracted from it. Make sure there's no numbers on the outside of it that are being multiplied or divided. So you need to isolate it. Second, create two cases. Okay, set the inside equal to both the positive versions and the negative versions of the numbers. Okay, solve both equations, and then step 4, check for an extraneous solution. Okay, these can have no solution. So, what are extraneous solutions? Extraneous solutions are a solution that we get, so a solution that we find, but does not work. Okay, it does not work as a solution because if we plug it back in, for some reason, it doesn't equal the original equation. And we'll go through one of those to double check and make sure we have it. Okay, so solve each equation, be sure to check for extraneous solutions. This first one, it says isolate the absolute value. In this case, absolute values are already isolated, so that's fantastic. The next thing it tells us to do is to separate it into two versions. We need a positive version, okay, and then we also need a negative version. Our positive version, nothing changes inside the absolute value, so that's going to stay x minus 9 is equal to 5. In this case, we would just solve for x by adding 9 to the other side, and we would get x is equal to 14. Okay. On the negative version of this, we're going to go negative x minus 9 is equal to 5. The reason we do the entire thing negative is because this entire thing could be negative, and then we could still get out a positive 5. Okay, so the entire thing must become negative. So you have options. You could distribute negative here, okay, or you could divide off the negative right from the beginning. That's what I'm going to do. You get x minus 9 is equal to negative 5. We add 9 to both sides, and we get x is equal to positive 4. Okay, so those would be our two possible solutions. Now we need to check to make sure they work. So we get the absolute value of 14 minus 9 equals 5. So that's the absolute value of 5 is equal to 5. So that one's good. We have the absolute value of 4 minus 9 is equal to 5. So that's the absolute value of negative 5 is equal to 5. So that one's also good. So then both of these are solutions that work. Okay? And that's how absolute value is going to go. So, number 4. Absolute value is isolated. We have our positive version. And then we have over here our negative version. Positive version, nothing changes inside the absolute value. So we have 3 is equal to 2k plus 7. In our negative version, that whole thing becomes negative. So 3 equals negative 2k plus 7. I'm going to subtract the 7 off from this positive one. It's going to give us negative 4 is equal to 2k. Divide by negative 2, or divide by positive 2, we get negative 2 is equal to k. On this other side, why not? Divide by the negative 1 gives us negative 3 is equal to 2k plus 7. Subtract 7 from both sides. Negative 10 is equal to 2k. Divide by 2, negative 5 is equal to k. Remember, double check your answers, right? So 3 is equal to 2 times negative 2 plus 7, absolute valued. That's 3 is equal to the absolute value of negative 4 plus 7, which would then be the absolute value of positive 3, so we're good. On this other side, we would have 3 is equal to the absolute value of 2 times negative 5 plus 7. Close the absolute value. So that's 3 is equal to negative 10 plus 7 in the absolute value. So 3 is equal to negative 3 in an absolute value. So then we're good there as well. All right, so then both negative 5 and negative 2 would be solutions to our problem. All right. Hopefully this is going okay for you guys. All right, number 5. So number 5, we have to isolate. Subtract 17 from both sides. Okay, we get y minus 1 is going to be equal to, what is that, 23 minus 17. Oh my gosh, I'm blanking. 3, 4, 16, so 6. And then from here, we can go y minus 1 is equal to 6, or negative y minus 1 is equal to 6. So then we add 1 to both sides. We get y is equal to 7. Divide by negative 1 from both sides. Y minus 1 is equal to negative 6. Add 1. Y is equal to negative 5. Now we just need to plug both of these in, make sure they both work. So on the left side we get 7 minus 1, okay, plus 17. We can actually use this equation right here. So 7 minus 1, does that equal 6? Well, absolute value of 6 is equal to 6, so we're good. And then negative 5 minus 1, and our absolute value is negative 6. So then that one also works, okay? All right, number 6. Isolate. Subtract 9 from both sides. Negative 4, absolute value x plus 10 is equal to negative 24. Divide by negative 4. We get absolute value of x plus 10 is equal to 6. Split it into our two cases. So x plus 10 is equal to negative 6. Negative x plus 10 is equal to 6. Sorry, not negative 6. This is positive 6. And then we just solve both of them, right? So x is equal to negative 4 on that side. And then we're going to get, I'll do this in two steps. X plus 10 is equal to negative 6, so x is equal to negative 16, okay? And then you guys can plug those in and check them, but I'm 99% sure they're good to go, okay? I just don't want to spend your whole time checking these questions in front of you, okay? I don't think that's worth it. I think you guys can just check on your own. So, number 7, we're actually going to change this problem, so go ahead and just grab white, and we're going to white it out. I want to pick a different problem here just for us to practice extraneous solutions. So the problem that we're going to write here is negative 2 plus the absolute value of 2x plus 3 is equal to 3x. The reason that this question becomes a danger question, okay, is because of this 3x on this other side, okay? So this is one where you know there could be some danger here because there's an x on the other side that doesn't have the absolute value. Whenever that happens, guys, you have to be super duper careful and make sure you're double checking for your extraneous solutions. So let's go through this question. To start this question, what you're going to do is you're going to isolate the absolute value. So we have to add 2 to both sides. Gives us the absolute value of 2x plus 3 is equal to 3x plus 2. okay? And then we have our two cases. Positive case says 2x plus 3 is equal to 3x plus 2. And then the negative case is going to be negative 2x plus 3 is equal to 3x plus 2. So then we're solving for x. I'm going to subtract 2x here. I'm going to subtract 2. And that's going to give us 1 is equal to x. On the other side, I'm going to distribute the negative. So negative 2x plus 3 is equal to 3x plus 2. Let's solve for x. So I'm going to subtract 3x from both sides. Subtract 3 from both sides. What does that give us? Gives us negative 5x is equal to 2. Oops, I did not distribute that correctly, right? This should be a negative 3. So then we're adding 3 to both sides, so equal to 5. Divide both by negative 5, we get x is negative 1. Okay? So I hope you guys caught me there, right? That should have been a negative 3. So we have x equals 1, x equals negative 1. So let's plug these in and see what happens. We can just plug them straight into this equation. We don't need to go all the way back to the beginning here. So we're going to go absolute value of 2 times 1 plus 3 is equal to 3 times 1 plus 2. That's going to be 2 plus 3 is equal to 3 plus 2, and we're good. Both are 5. On the other case, we're going to go 2 times negative 1 plus 3 is equal to 3 times negative 1 plus 2. This gives us the absolute value of negative 2 plus 3. On the other side, we get negative 3 plus 2. So then the absolute value of 1 equals the absolute value, or equals negative 1. Okay, so right here, we messed up, right? 1 is not equal to negative 1. So then this is an extraneous solution. And I would want you to write that. Extraneous solution. And then 1 does work, so then we would box that answer. Okay. So those are all really good examples of absolute value problems. Okay. I'm not worried about the last one too much. I think you guys have got a good handle of all of this going on. If you try this one on your own, though, remember you just have to isolate the absolute value. Once you do that, you split it up into its positive case and its negative case, and then you solve for k. So, the last part of this, graphing absolute value functions, okay? I'm going to show you a different way than the way we did yesterday, but if you like the way we did yesterday, by all means, don't feel like you need to change anything here. So, when we look at absolute value functions, it's actually the slope of it's actually just two linear equations combined. So what happens is the slope is actually the a value of the linear equation. So in this case, 1 over 1 is the slope. So then I'm going to take the shift. Okay, so the shift is negative 1 down 3. And then just like the second method that we did yesterday, that's my new origin. And then I just apply the slope. So the slope is 1. So I go up 1, right 1, up 1, right 1. Up 1, left 1, up 1, left 1, bam, absolute value graph is done, okay? So, how to do that again? This time a little bit different slope. Right now our slope is 2 over 1. Shifting negative 4, 1, 2, 3, 4, puts us here. So then that is our new origin. And then from here we're going to go up 2 to the right 1, up 2 to the right 1. And then the other side is going to be up 2 to the left 1, up 2 to the left 1. Okay, so it's literally negative 2 over 1 and 2 over 1, right? That's our two slopes of these lines that are getting built. All right, next one. So hopefully you think this is a really fast way to graph absolute values. So shift right 3 and up 1, so 1, 2, 3, up 1, so then this is our new origin. Now we follow the slope. Slope is 1/2, so then we're going to go positive 1/2, and we're going to go negative 1/2. Right, so up 1 to the right 2, up 1 to the right 2, up 1 to the left 2, up 1 to the left 2. Graph it, bam. Dunzos. All right, last one. Last one, shift left 2 and up 4, so 1, 2, 1, 2, 3, 4. That's our new origin. Okay, this one a little bit trickier. This is saying that negative 3/2 is our slope. Okay, when it is negative to start with, that automatically means it's going to open down. So it's saying 1, 2, 3 down to the right 2. Bam. Okay, 1, 2, 3 down to the right 2. That's one side of this graph. And then on the other side, we're going down 3 to the left 2, down 3 to the left 2. Okay. And then just like that, we've just graphed four absolute value graphs in literally like 5 minutes, less than that probably. Okay, so absolute value graphs can get graphed really fast if you learn this method. Literally, it's just the slope is the a value, and then apply the shift at the beginning. Okay, so as always, if you have any questions, guys, shoot me an email. Okay, make sure you try the homework tonight and be ready for the skill check tomorrow. Okay, we're doing skill check 1.1 to 1.3. All right, have a great rest of your day.